Hello, Mr. Simmons here, and I'm going to go through the kerboodle worksheet with you in this video for topic P8.2, forces between objects. And I've had a few emails saying that people have struggled with understanding of this one, so I thought it was worth spending a bit of time going through the answers to the worksheet as well as the textbook, which I've already posted this week. So, after completing this activity, you should be able to identify contact and non-contact forces, identify action and reaction pairs of forces, and explain change of motion due to the action of forces. Now, the textbook questions were mostly focusing on that last bullet point of explain change of motion due to the action of forces. This worksheet is mostly focused on the action and reaction pairs of forces, and this is the bit that people are having a little bit of difficulty understanding. So, setting the scene, it says whenever two objects interact with each other, they exert equal and opposite forces on one another. Now, the on one another point is important here. In other words, that when one object puts a force on the second object then puts its reaction force on the first object. So the two forces in the action and reaction pair are acting on different objects. So this can be referred to as action and reaction. When the two objects touch each other to interact, it is called a contact force. If the objects do not need to touch each other to interact, it is called a non-contact force. Now, this is a bit easier to understand with contact forces than it is with non-contact forces, which we'll see. The first few questions are about contact forces, and then it gets on to non-contact, which makes it a bit more difficult. So the following is a description of high diving. Read carefully, then answer the questions. I'm not going to read through all of this now because I'm a bit limited for time. What I have done is I've put on here a link to the Red Bull site, which I think is where they got this information from. And I've got a few pictures from there as well. So you can see in the sticky note over there the link, and I'll put a hyperlink in the description of this video as well, which you can just click on to go to that site. Have a look if you're interested. It does go through and explain in particular a little bit about the effect of the forces on the divers and what the divers do to help control those forces, make sure they don't injure themselves when they're doing this. So on with the questions then. Name one contact force and one non-contact force acting on the diver as they are falling through the air. So possible contact forces listed, and you've got these answers already. I sent these out a couple of weeks ago. In fact, the possible contact forces are air resistance, drag, and it says allow friction. Normally friction is used to describe the force when two surfaces, so solid objects, are rubbing together, but you can use it when we're talking about non-solid things, fluids, liquids, gases as well, like the air. And push of air on diver is a bit more descriptive, but really all three of those things are describing the same thing, which is basically air resistance or drag. Possible non-contact forces: gravity, weight, and gravitational attraction of the Earth on the diver. And again, those three are really describing the same things. They're describing the fact that the Earth is pulling the diver down towards it. Name one contact force and one non-contact force acting on the diver as they enter the water. So, possible contact forces: drag, water pushing against diver, allow friction again, as I discussed before, push of water on diver, and upthrust. Now, upthrust is not so much the best word for describing this. Normally we talk about upthrust as the force which is causing things to float in the water, so it gives an object buoyancy. But you could use the word upthrust here because once they enter the water, whether they're moving or not, they will be experiencing upthrust. It's just that that force is going to be a lot less than the force of drag as they enter the water at high speed. For the non-contact forces I didn't mention, so they are the same as for number one. Whether the diver is in the air or in the water, it's gravity or weight or gravitational attraction on Earth, of the Earth. So for number three, for the contact and non-contact forces you named in question 1, identify their equal and opposite force. Now this is the bit where the non-contact force starts to become a little bit more difficult to follow. So diver pushing on air. So the contact forces you named in question 1, you can see up the top there, air resistance, drag or push of air on diver. So that's the air pushing on the diver as they fall through the air. So the equal and opposite force to the air pushing on the diver is the diver pushing on the air. So as they fall through the air, they are going to kind of plough through the air and push the air out of the way. So that's the force that's being described there, the diver pushing on the air. And here's where it gets a bit weird. Gravitational attraction of diver on the Earth. So I've put a little diagram here. You can see the little cartoon character of Einstein there. And you can see there's a force pulling him downwards towards the ground. And that's labelled as F equals mg. That is the equation. Force pulling him down is equal to mass times gravity. So that's his mass times the force of gravity due to the Earth, which is about 10 meters per second squared, the acceleration due to gravity from the Earth. And then you can see at the bottom of that picture there's an arrow pointing upwards from the ground where it says F equals negative mg. Now that's showing the fact that Einstein, as he's falling there, is actually pulling up on the Earth with an equal force to the force of the Earth pulling down on him. So that's the bit that people are kind of not really getting. Whenever there are two objects, any two objects in space that are close enough to each other for gravity to affect them, then they both pull on each other with an equal and opposite force. So an example is the Earth pulls on the Moon. That keeps the Moon in orbit around the Earth, but the Moon is also pulling on the Earth with an equal and opposite force. It's just that the force of the Earth on the Moon has a big effect on the Moon's motion, whereas the force of the Moon on the Earth has almost no effect on the Earth's motion. It does cause the Earth to wobble a little bit. It has more of an effect on the water on the Earth as it causes tides. But the effect of the Moon on the Earth is much smaller because the mass of the Earth is much greater than the mass of the Moon. And it's the same thing with a falling diver. The diver has very little mass, almost no mass compared to the Earth, so the equal pull between them affects the diver and moves the diver towards the Earth, because it's almost impossible for that tiny force to actually move the Earth, the whole mass of the Earth. Okay, question 4. For the contact and non-contact forces you named in question 2, identify their equal and opposite force. So these are the ones that you can just see at the top of the screen, on the logos probably covering them. There you go, you can just see at the top of the screen there. So drag, water pushing against diver, allow friction. That would be the diver pushing on the water then, the equal and opposite force of that. And then, as we've just been explaining, for the diver pulling on the Earth, there's an equal and opposite force there. That's the non-contact one. Okay, extension. Explain why in terms of forces there's a risk of head injury when diving from this height. Suggest why the high divers would choose to enter the water feet first. Well, if we go back up to the description, you can see where it says from this height divers can take up to 3 seconds, with divers reaching speeds of 90 kilometers per hour before entering the water. So that's the sort of speed that you'd be driving along the motorway at. So when the drivers enter the water, they are pushing on the water with a great deal of force. And the water pushes back with an equal and opposite force. Now you can see in the picture there the diver entering the water and pushing the water out of the way. The water is pushing back on the diver as they enter the water. Now, going at that speed, water is actually a pretty hard surface to hit. If you try sort of slapping bath water or water in a swimming pool, then you know that you can feel that force quite strongly as you hit the water, it pushing back on your hand. And if you've ever been unfortunate enough when diving into the water to perform a belly flop, then you'll know that actually that can make you quite sore. This is something that's actually been in the news quite a lot recently, because there were some divers jumping off cliffs in a part of Dorset called Durdle Door, and a couple of them have been quite significantly injured as they hit the surface of the water, and helicopters had to be called out to extract them from the beach there. It's been all over the news recently. So divers, it then says, want the smallest possible surface area to be presented to the water. So if they are entering the water feet first, the tips of your toes, if you point your feet, that's a much tinier surface area than the top of your head. If the diver enters feet first, by the time their head enters the water, the diver has slowed down. So it did say in the description above, the water stops the divers in less than a second, and they rarely go deeper than 4 meters. So that just highlights the point there that if the diver enters feet first, by the time their head enters the water, the diver has slowed down. Okay, so it says a mark for each relevant point, maximum of 3 marks. So any 3 of those would have got you 3 marks if this was an exam question. Question 6. The text describes the diver as falling through the air for 3 seconds and then being stopped in the water in less than a second. Describe the motion of the diver as they enter the water and explain it in terms of the forces acting on them. Give 1 mark for each relevant point, maximum 4 marks. To gain full marks, students must make 1 relevant point about the motion of the diver. So the points that are about the motion of the diver is the diver decelerates, or from the bottom of the diver accelerates upwards. It actually means the same thing. So decelerating as they're falling downwards is the same thing as accelerating upwards as they're falling downwards. Their speed will be reduced. It's negative acceleration or deceleration. Once in the water, the diver experiences upthrust. The force is in an opposite direction to the weight of the diver. Upthrust in the water is greater than weight. The resultant force is upwards. The drag force in water is greater than the drag force in air. So any 4 of those points will get you a maximum of 4 marks for this question, but you must have included one of those 2 highlighted points about the motion, decelerating or accelerating upwards, or negative acceleration as they enter the water. Okay, right, so that's the worksheet for kerboodle I've gone through, and if you've got any more questions about this, if there's anything that you're still struggling to understand about it, please do get in touch with me via email and I'll try and help you out. Okay, cheerio and stay safe. Thank you. Bye.